Welcome again, everyone, to the 8th Annual Society of Creation Conference. It's my distinct privilege and pleasure to introduce our keynote speaker, Spike Psarris. Spike has a degree in electrical engineering and has done graduate work in physics. He worked in his career in the U.S. military space program, and interestingly, he began his working career as an atheist committed to evolution. But through his scientific investigation, he was convinced of the truthfulness of creation, and that ultimately led him to the Creator. Spike has his own ministry and organization. He will talk about that. It's Creation Astronomy, and you can find them conveniently online at creationastronomy.com. Spike is a music lover and a musician. And I hate to start the presentation on such a down note, but he shared this really sad story with me about this famous musician. He said, "Did you hear about this famous musician who committed suicide?" I said, "No, that's terrible." He said, "Yeah, and he died without leaving a note." So on that happy note, I'm going to turn it over to you, Spike.
Thank you, Dr. Locklear. Something I should have mentioned in my previous presentation, Zoom in its infinite wisdom is treating my microphone as if it's part of the background and is removing it. So if I do this, sometimes you can see a piece of the equipment, and sometimes it's just removing chunks of my head or face. Now, arguably, removing parts of my face might actually improve my appearance, but if that was maybe disconcerting to some people, I figured I'd mention that. Zoom isn't necessarily an ideal medium for someone like me. I've been told I have the perfect face for radio, but Zoom is what we have, so that's what we will continue with. And if I share my screen like so, hopefully everybody can see that.
Got it.
My topic is our Goldilocks Cosmos. Privileged to speak on this as the last session in our conference here today. I will note up front that some of the topics I will discuss had been mentioned previously, whether by Dr. Locklear or Dr. Humphreys. You've probably noticed that a few of the topics do overlap a bit, and we are talking about these things because they're important. And hopefully hearing about them more than once will reinforce them. Also, as I cover my topics, I like to be systematic, and so I like to mention things even if they've already been mentioned, just to provide a thorough coverage of a topic. So what does it mean to be Goldilocks? Well, we're probably familiar with the story of, oops, I guess I need to do this, don't I? Sorry about that. Probably familiar with the story of Goldilocks and the Three Bears, and how Papa Bear's possessions were always one characteristic, and Mama Bears were always at the opposite end of the spectrum, but baby bears were just right. So Papa Bear's porridge was too hot, and Mama Bear's was too cold, but baby bears was just right. And we can apply sort of this perspective to the cosmos as we examine different characteristics of it. There's many aspects of the cosmos, of our planet, our solar system, and so on, that have a range of possible values, and those different values would vary in their ability to support life. And over again, we see that all these characteristics, they're not too hot, they're not too cold, they're just right. They're not one extreme or the other. They're right where they need to be to seem to be ideal for us to be here. So we're going to talk about the Earth, this being the planet we live on. We've learned a lot about it, of course. We're going to look a little bit about the solar system that our Earth is within, the Milky Way galaxy that the solar system is within, and even the universe itself, the entire cosmos. And we're going to ask the question, do these things look like they are the outcome of random processes, of just the laws of physics working themselves out over time? Or do these things actually look designed? Well, obviously, I'm going to argue for the latter answer. And I also like tying into what Dr. Locklear was saying. Creation is a reasonable explanation, and non-creation is non-reasonable. One of my primary points here in this last session is that if you take the secular viewpoint to its logical conclusion, you wind up in a place where, if you're a secular thinker, you probably don't want to be, showing that your viewpoint actually is not a reasonable explanation of the cosmos that we exist within. Now, the Bible says that in the beginning, God created. the heavens and the earth. And hopefully this is a familiar verse to all of us. Indeed, the Bible affirms over and over again that the Lord is the author of physical reality, of the universe and everything within it. So we can expect, therefore, to see evidence of his created handiwork within it. However, our society tells us, our culture tells us, this is not a reasonable explanation. This is not a scientific explanation. This is not allowed within the discussion. Why is that? Because this is a supernatural explanation. Now, supernatural, the prefix super just means above or beyond. So something that is supernatural is something above or beyond or outside of the natural world. And we are told that only naturalism is an allowable approach within science and the origins discussion. We can only invoke natural processes to explain the world we see around us. Now, the Bible says that the Lord created things for signs and seasons, to sustain life on earth, and to declare his glory. And I'm going to argue that the cosmos is in concordance with this explanation and shows evidence of these purposes as part of its design, rather than being the outcome of, again, just the laws of physics working itself out over time. And even some secular thinkers are actually straying towards this way of looking at things without being theistic about it, without saying there is a God. Many secular scientists are at least admitting that we live in a very unusual location. We have a lot of unusual things going in our favor. The idea that there's all these planets out there that look just like ours, and so there's probably life scattered through the universe, is not looking reasonable as we learn more and more things about the universe that we live in. And as I'm showing on the slide here, even though secular scientists are recognizing this, they aren't going far enough in their thinking. As I will discuss later, I'm going to take their secular viewpoint to its farthest conclusion and see where we wind up with it. And as I said, we're going to wind up in a place and show the logical implications of the secular viewpoint. And we're going to wind up in a place that most secular thinkers aren't willing to go to because they realize that this shows the unreasonableness of their position. So the secular model today, the overall vast majority of secular thinkers who deal with cosmic origins believe in the Big Bang model, that in the beginning, there was a quantum fluctuation of the vacuum. There was nothing, and then suddenly there was something. Something burst into existence out of nothing and blew up and made a lot of energy, which cooled and condensed into matter, which cooled and condensed into objects such as stars, which gathered together into galaxies, and then planets formed. And then here we are on one of those planets today, looking at all of it later. So basically nothing fluctuated and made everything. Well, is this a reasonable idea at the very beginning of the discussion? Can nothing fluctuate? Is nothing something that has the property and the ability of being able to fluctuate? Well, no, nothing doesn't have any abilities because nothing has nothing. Nothing is nothing. Nothing cannot make everything. Setting aside the problems with that, though, we're going to, if not actually endorse this, we'll at least accept it for the sake of argument. And throughout my talk here, I will be putting on my evolutionist hat, so to speak, and saying if I were actually thinking as a consistent evolutionist, and especially as a consistent atheist who is an evolutionist, then I would actually have to say that the following things are true. And we're going to see that some of these things are not reasonable to believe. So accepting for, excuse me, let me slow myself down here. Accepting for the sake of argument that the Big Bang model is our overall paradigm, does our Earth and the context within which we live support this way of looking at things? Well, the Earth is the planet that we know the most about because we live here, we've been studying it, and we have the opportunity to take lots of close investigation and measurements of it. And as I covered on my previous talk, the Earth supposedly formed from a solar nebula some 4.5 billion years ago. We talked about the problems with that and the inconsistencies of the various planets with this potential proposed origin. What about design characteristics? Above and beyond the issues with just getting it in the first place from a gas cloud, does it appear to be the product of random processes? Well, the Earth exists within what is called the habitable zone of our solar system. So the habitable zone is a region within which water is possible, a distance from the central star within which water is possible. Now, if you think about it, if you're too close to the sun, if your planet is too close to the sun, then liquid water will not be possible because it'll be too hot and the water will vaporize and turn into steam. Conversely, if your planet is too far from the sun, then you'll be too cold and liquid water won't be possible because it will all be frozen. But there's a region in the middle, that Goldilocks area, the Goldilocks zone, where it's just right. It's not too close and it's not too far. It's not too hot and it's not too cold. That narrow region is where liquid water is possible. And if you follow science and especially astronomy, you'll frequently hear uh, announcements of discoveries of planets in other solar systems. And people will say, well, we found a planet in the habitable zone of the star, so maybe there's life there. Because they think that they imply in the way that these things are worded that merely being in the habitable zone is the major characteristic that you need to have in order for life to be possible. Well, as Dr. Locklear has mentioned, life can't form on its own anyway. There's very good chemical reasons why formation of life from non-living chemicals is actually impossible. So this discussion really is dead coming out of the gate anyway. But my point for right now is just being in the habitable zone is not sufficient by far to show that life is possible somewhere. I mean, even within our own solar system, there's another body within the habitable zone, and that would be the moon. Well, is the moon amenable to life? Is it supportive of life? Well, no, it's a very hostile environment. Just being in the habitable zone, just being in a place where liquid water is possible, doesn't mean A, that liquid water is there anyway, or B, that other characteristics necessary to support life are available. So the additional problem also with this idea, and I talked about this briefly in my solar system talk, we're in the habitable zone of our solar system today, but that's because conditions today would allow liquid water to be possible here. However, liquid water could not have formed here initially from the gas cloud, as I mentioned in my last talk. So that's another wrinkle to this habitable zone discussion that often isn't brought up. The presence of water is not only dependent on the distance from the star today, but also dependent on whether water could have formed there in the first place. And as we see in the Earth, specifically, the answer to that is no. But there's a lot more to talk about with the possibility of supporting life than just the presence or absence of liquid water. The Earth is actually uniquely designed for life. There are many features that support life. For example, our magnetic field protects the Earth to some degree from radiation from space, at least a little bit. It does that by channeling it down elsewhere. It has a larger effect over the long term of preserving and retaining the Earth's atmosphere. Without the magnetosphere, solar radiation and cosmic rays would, over time, strip the Earth's atmosphere away. And among other, of course, that would be very bad for us if we were living here in those circumstances. It would also eventually make liquid water impossible on Earth, as I talked about with Mars. The reason Mars can't have liquid water is because its atmosphere is too thin. Now, this is one of those ways of looking at things, one of those arguments that is more applicable to a long-age thinker than to a creation thinker. So over a period of thousands of years, our magnetic field won't necessarily have a large impact on our life, although it does affect other creatures in different ways. They use it for different purposes. However, if I were actually an evolutionist and believed in the billions of years, I would have to acknowledge that this is actually a design feature. Whether or not I believed in a designer, I would have to agree that this is actually necessary for life to be on Earth, because over long periods of time, if this magnetosphere were not here, then life here would become very difficult. Other aspects of our planet that support life is our rotation period. Now, this is something we probably don't think about. I mean, who woke up this morning and thanked the Lord that he made the day just 24 hours long? I mean, we don't think about this. That's just how our planet is. Yet, when we look elsewhere in the solar system, we see that a variety of rotation periods are present in different planets, and that ours turns out to be just right for life to exist here. 24 hours turns out to be a Goldilocks value. It's just right. If the Earth rotated significantly more quickly, then we would start to have violent winds on our planet. Conversely, if it rotated more slowly, then the day and the nighttime periods would be longer, which means that if any point you were on the Earth's surface, you'd be exposed to the sun's heat for longer, meaning you would get, of course, hotter, your environment would, and then you'd be on the night side for longer, so it would cool off more. So if the day were substantially slower, we would start to have more pronounced temperature swings on the Earth. But 24 hours turns out to be just right. And again, looking at other planets in the solar system, we can get some perspective on this. For example, Jupiter has a day that's only 10 Earth hours long. And I'm thinking of a planet as large as that and rotating that quickly. You can imagine the how quickly that thing is spinning. But point is, that apparently is a viable option for a planet to be rotating that quickly. So this helps us to be thankful that the Earth doesn't rotate that quickly. The opposite extreme is Venus, which has a day of 243 Earth days long. So it takes 243 Earth days to rotate once. There was a question in the conference previously about why did God create the diversity of planets that he did within the solar system. He did that for a variety of reasons to declare his own glory, and some of those ways we probably haven't even realized yet. But I personally think that one of the reasons he created the planets in the way that he did is to give us some perspective. If the Earth was the only planet that we knew about, we would just take it for granted. We would assume that our day is what days are. We would assume other things, other characteristics are just the way a planet should be. But even within our own solar system, we see such a wide range of possible values for some of these characteristics. It helps us to appreciate better what the Lord has done here on Earth for us. For example, our axial tilt. Our planet is tilted over by about 23.5 degrees. Now, this gives us our seasons, because at one point in the year, the northern hemisphere is tilted toward the sun. So that is summer here in the northern hemisphere and winter down in the southern hemisphere. 6 months later, the Earth is on the other side of the sun. So now the southern hemisphere is tilted toward the sun. So it's summer there, and the northern hemisphere is tilted away, thus giving us winter in the north. Now, 23.5 turns out to be a really good value for moderate seasons, which is what we have here on Earth. And again, this axial tilt is not an inevitable thing. There's a wide range of values that it could have. For example, Mercury shows us that a planet can exist just fine with basically no axial tilt. Mercury's tilt is only 0.01 degrees. It's basically zero. So there are no seasons on Mercury. If the Earth were like this, then it would always be very much hotter at the equator than the poles. And again, life here would be very different. The other extreme of this is Uranus, which basically, as I mentioned in my solar system talk, rolls along sideways like a ball. So if the Earth were like this, then one pole would be pointed at the sun for a while, and then it would, as it went around the sun, gradually the other pole would be pointed. There would be wild extremes in temperatures here because one hemisphere would be basically continually exposed to sunlight for days, if not months at a time. But we don't have that on Earth. We have a 23.5 degree tilt, which again is just right. Our orbit is also very circular, again, very conducive and supportive of life here on Earth. So if you look down at our solar system from above, this is not to scale, of course, but just to show the sun is in the middle and the Earth going around it, our orbit is almost a perfect circle. So our distance to the sun is basically constant throughout our year. This means that the amount of energy we receive from the sun is constant throughout the year. Now, again, this isn't inevitable. We'll see this, for example, in Mercury. Mercury's orbit is more eccentric, meaning it's more of an ellipse, like we see here, more of an egg shape. And so at one point in its orbit, Mercury is much closer to the sun than at a different point in its orbit. In fact, Mercury actually receives twice as much energy from the sun at its closest point compared to its farthest point. Now imagine if the amount of energy we receive from the sun here on Earth went up by a factor of 2 just in a matter of 6 months, and then went back down to the original value and then kept doing that cycling back and forth. I mean, you want to talk about climate change, right? The Earth would basically be uninhabitable or something close to it. But again, this is not our situation. Our orbit is nice and circular, which is very conducive, very supportive of life on Earth. And the same is true of our atmosphere. We mentioned previously that Venus has a very thick atmosphere consisting of very heavy cloud cover, so thick that we can't even see the surface from space. This has created a runaway greenhouse effect on Venus. Sunlight comes in, is absorbed by the surface, re-radiated back out, and then the heat is trapped by this thick atmosphere. As a result, even though Venus is Earth's sister planet, quote unquote, basically the same size, mass, and composition, Atmospheric pressure on the surface of Venus is 92 times that of Earth, a crushing amount of pressure. And its surface temperature is almost 900 degrees Fahrenheit. I mean, if there's a place that matches the biblical description of hell in the solar system, it's the surface of Venus. Not a place you would want to try to be on. This very dramatic difference, though, is all because of its atmosphere being a different thickness and composition of the Earth's. The opposite extreme compared to Earth is illustrated perhaps by Mars with a very thin atmosphere. Like we talked about previously, the fact that Mars' atmosphere is thinner than Earth's makes it impossible to retain liquid water there, which is why the surface is a desert planet today. But our atmosphere is not at either of those extremes. Our atmosphere is just right. It's not too thick, which would produce a greenhouse effect, yet it is thick enough to give us air to breathe and protect us from radiation from space and some other benefits as well. So it's not too thick, it's not too thin, it's just right. So is this the outcome of random processes, just of the laws of physics working themselves out over time? Or is this because the Earth was designed for life? Well, I would say these and many other characteristics supports the idea of design. And not just for the Earth, for the whole system overall, the sun and the Earth and even in the moon, as we'll see for a moment. And none of this should surprise us because as the Bible says, thus saith the Lord that created the heavens, God himself that formed the earth and made it, he hath established it and created it not in vain. He did it for a purpose. What was that purpose? Well, he formed it to be inhabited. I'm the Lord and there's none else. So if an omniscient, omnipotent, and benevolent creator made the earth and the surrounding system as a place for us to live, to be inhabited by us, then we shouldn't be surprised that it does that very well. And that's exactly what we see. And not just the Earth, even our moon has design characteristics. For example, the moon raises tides in the Earth's oceans. Now, it turns out that these tides are very beneficial for us because if the moon weren't there doing that, then the tides would be much less. I mean, the sun would still raise some, but ocean water would risk becoming stagnant because the tides actually help in circulating the oceans. And if the oceans become stagnant, then things start to die. That spreads through the whole food chain, including us. So the moon is actually quite important in sustaining life on Earth. However, if the moon were much closer to Earth or much larger than it is, more massive than it is, then the tides would actually be destructive to Earth's coastlines. Conversely, if the moon were smaller or farther away, then the tides would be less, and again, we're risking getting stagnant in the oceans again. But it's neither of those values. It's just right. It's a Goldilocks value right in the middle. It's also uniquely positioned. The moon is 400 times smaller than the sun is, but it's 400 times closer to us than the sun is. Therefore, in the sky, they have the same apparent size from our perspective as we're looking at them. And the moon has an orbit in such a way that sometimes it passes in between the Earth and the sun. And when it does that, if you're in the right place on the Earth's surface, you can see a total solar eclipse where the disk of the moon just exactly blots out and blocks the disk of the sun. Now, this allows us to do some good science. For example, we can observe the solar corona, which we normally can't see because the sun is too bright. It also supports the idea of signs and seasons, as the Bible talks about these objects being created to provide. And there's a design implication here too. As Dr. Locklear mentioned, there's many other moons elsewhere in the solar system, well over 160 at last count. And of all of those moons, how many of them have the proper combination of size, orientation, and orbit relative to the planet it's orbiting to produce events like this for observers on its surface? And the answer is one. Our Earth and moon is the only combination of planet and moon that we know of in the solar system that produces these events for observers on the surface. And as an astronomer friend of mine has commented, kind of tongue-in-cheek, he's a Christian, he says, isn't it an amazing coincidence that the only place in the solar system where these events happen is the only place in the solar system where there are observers to see them when they do? This is an argument for design. The moon is also stabilizing to the Earth. What do I mean by this? Well, it turns out that as the moon orbits the Earth, it actually stabilizes our spin on our rotational axis. And people have calculated that if the moon were not there, that Earth would have some problems. Our axial tilt would vary chaotically from 0 to 85 degrees. So it would go from no tilt at all to being all the way over on its side. Now, this again is one of those things that applies over to millions of years, not on thousands. So as young age thinkers, this isn't something that we have to account for. But again, if you're a long age thinker, if you believe in the billions of years and all the rest of it, you have to acknowledge that this system is well designed to support us over long periods of time. And that if it weren't that way, things here would be very different. The moon was created to support life on Earth and to support those other purposes that we saw in Scripture. Doesn't look like the outcome of random processes. There's many arguments for it being designed to be, as the Bible says, the lesser light to rule the night, which is a role that it fulfills very well. And since I mentioned the lesser light to rule the night, that probably brings to mind the greater light that rules the day, and that would be our sun. Now, a lot of us don't necessarily think about how well designed the sun is. I mean, the sun goes up every day and it goes down and we go about our business. We don't think about it. But the sun is really amazing. First of all, we are utterly dependent on the sun for life to be possible on Earth. And there's many ways in which this is true. First of all, the sun provides warmth for us. Without the sun warming the Earth, the only source of heat here would be radioactive decay within the crust. And there's a little bit of that, but not a whole lot, certainly not enough to keep the planet warm enough for us to be here. It also is ultimately the source of all of our food because plants need sunlight to grow, and plants are the base, and along with plankton and algae in the oceans. And those things are the foundation of the food chain. Other things eat those, and then we eat those other things, or in some cases, we consume the plants directly. In any case, sunlight is necessary for all of this to be possible. The sun is really the source, in a sense, of all of our food. It's also the source of our oxygen. Oxygen is produced during photosynthesis. That's the result of plants interacting with sunlight, right? So the sun also gives us the oxygen that we breathe. Now, an atheist isn't necessarily impressed by any of this because the atheist thinks that the sun is just this mediocre thing. As Carl Sagan said, who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies than people. So he doesn't sound very impressed by our sun, does he? It's just humdrum. This author says, our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity. This author says, our sun, so important to us, is merely an ordinary garden variety star. Are these types of statements true? Well, no, they are not. Our sun is not at all mediocre or average. First of all, it's brighter than 90% of all stars in the Milky Way. Second of all, it has more mass than 92% of all stars. So we're already seeing that our sun is very unusual. In fact, about 3/4 of all stars are red dwarfs. What is a red dwarf? Well, a red dwarf, as you can gather by the name, is small and red. And it's red because it's much cooler than a star like our sun is. In fact, a red dwarf only puts out about 5 to 10% of the energy of our sun. So if our sun were an average typical star, it would be a red dwarf because this is what an average typical star looks like. Again, 3/4 of all stars are just like this, red dwarfs. But we should be thankful that our sun is not a typical star because if it were indeed typical, if it were indeed a red dwarf, life here would be very different, if not probably even impossible. Why do I say that? Well, because red dwarfs are so much cooler than our sun is, to stay warm enough for life to be possible, our planet would have to orbit a red dwarf very closely. In fact, the Earth would have to orbit so closely that it would be tidally locked to the star. A tidal lock means that the orbiting object always faces the same side toward the object that it's orbiting. So for example, the moon is tidally locked to the Earth. You probably know that the same side of the moon always faces the Earth, even as it goes all the way around our planet. Well, the same thing would be true of the Earth if our sun were a red dwarf and if we were orbiting closely enough to be warm enough for life to be possible here. And the Earth being tidally locked to the star, of course, would be very bad because that means one side of the Earth would always be roasting and the other side would always be freezing. And of course, this is not conducive to life here. Moreover, you do not want to orbit a red dwarf star this closely. Why is that? Because red dwarfs are very unstable. They're often called flare stars because they flare so frequently. Massive eruptions of material blasted out into space. And if any planet's in the way, well, you can imagine what effect that would have on life on that planet. So we're thankful right out of the gate here that we are not orbiting an average typical star because life here would probably not be possible. What about higher mass stars? Well, even those aren't conducive to life. For example, about 80% of higher mass stars are in binary or multiple star systems. And if you're in a multiple star system, that means there's multiple stars in the middle. Sometimes you're looking at just one because maybe they're obscuring each other, one's behind the other. And other times you're looking at more than one and receiving radiation from more than one. So the amount of radiation that a planet receives in a multiple star system varies dramatically over time. Again, making a stable climate on such a planet very difficult, if not impossible. So we should be very thankful that we are not orbiting one of those systems. I should say one of those, within one of those systems. Now, our sun is a class G star, which is only about 7.5% of all stars. So again, we're seeing the sun is very unusual. Even within class G stars, though, our sun is very, very unusual. For example, a 30-year study of the photosphere was concluded a few years back, and over that 30-year period, the energy output of the sun varied by 0.1%. Basically, it was constant in temperature throughout, is what the authors of the study said. Now, again, we take this type of thing for granted. We don't worry about the energy output from our sun varying over time. It just does what it does, and we go about our daily business. But this is an amazing find because stars don't behave this way. Even stars that are the most like our sun, even solar type stars, the ones that we have studied, it has been found that even solar type stars have frequent eruptions. They have super flares about once a century, as this study here found. What is a super flare? Well, you've probably seen images and movies like this one showing the activity that happens on the surface of our sun. And there's lots of cool stuff happening here that I'm resisting temptation to talk about. But periodically, there are eruptions of material going off into space accompanied by flares, as you see here. And some of these can be pretty large compared to the size of the Earth. But as large as these are, they haven't really, through history, had much of an impact on Earth. I mean, there's been a couple of incidences where like a power grid gets knocked out or something like that. But overall, things here in our solar system have been pretty calm. But take one of these flares, an average solar flare that we see happen here, multiply it by 10 million times. 10 million times one of these, that's a super flare. And that's what a solar type star normally produces frequently. How frequently is that? Well, as the study found, sun-like stars normally produce a bright super flare about once per century. I mean, that's scarily often if our sun were to be doing that. However, our sun has never done that. As this article notes, why a super flare has not occurred on the sun in recorded history is unclear. Well, it's not unclear. Just go read your Bible. The Lord created the earth and sun as a place, as a system for us to live within. So we shouldn't be surprised that it does that very well. Our sun is unique among stars in its stability and its quietness, if I can use that word. Just for perspective on how bad it can otherwise be out there. There's a star in the middle of this that's in the process of exploding, and the outer shell is now larger than the orbit of Jupiter. So if our sun did something like this, everything within the orbit of Jupiter, which includes Mercury, Venus, Earth, and Mars, would be consumed by this. Here's another star exploding in two different directions at once. There's a star in the middle of that, blowing up. Stars are not nice, stable, quiet things. I mean, twinkle, twinkle, little star, we see these little things in the sky. These are violent objects, frequently doing catastrophic things to whatever's in the environment around them. But our sun doesn't behave this way because it was designed to support us. As this author said, some of the popular perception of the sun is downright wrong. Writers sometimes tell us that it is just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the sun. This author said, people say the sun is a typical star. That's not true. Almost all environments in the universe are terrible for life. It's only Garden of Eden places like Earth where it can exist. So is it reasonable to say that a unique star like this is the outcome of random processes? Or does it reflect design? Because our sun is indeed unique in its ability to support life here on Earth for us. What about looking out on a larger scale outside of our solar system? What about our galaxy and the context within which our solar system exists? Are there any arguments for design here? Well, yes, there are. What if our sun, for example, was within a globular cluster? Well, this wouldn't be good for life. Astronomers refer to globular clusters as dead zones, meaning life is not possible there. First of all, the stars there are metal poor. They don't have the right composition chemically to have planets around them where life is possible. And again, we're thinking of like evolutionists here. We're assuming that planets form from the same gas cloud that the stars did, etc. But I think it's interesting that even if you think in those terms, the Lord has made the universe in such a way that it causes problems for people who try to deny his authorship of everything. An additional problem here is orbital perturbations. The stars within these clusters are very close together, so a planet orbiting a star is going to be constantly pulled on and tugged on by nearby stars, making its orbit around its parent star very irregular and perturbed, and which again would vary dramatically the amount of warmth and radiation that it receives from the star at the center of the system. Again, making the climate there just as variable. So we should be thankful that our star is not within a globular cluster. And the same is true for an elliptical galaxy. Stars aren't conducive to life there either within elliptical galaxies because they too are dead zones. The stars there are also metal poor and they have elliptical orbits within the galaxy, meaning, again, lots of interaction potentially with other stars, but more specifically here, moving closer to and farther out from the center of the galaxy where there's a higher level of radiation and so on. No, if you want to have a nice system that's conducive to life, then your star needs to be within a spiral galaxy, which of course our Milky Way is, but not just anywhere within a spiral galaxy, because the center of a spiral galaxy is also a dead zone because there's a lot of supernova explosions, gamma ray bursts, neutron stars, and other nasty things happening that are not going to be friendly toward life existing. Nor do you want to exist out on the edge because many stars there are metal poor, again, not conducive to life. You want to be roughly halfway from the center to the edge, and indeed that's exactly where our sun is. Moreover, not only is our sun placed in a location that's conducive to life, whereas other locations would not be, it's also been placed in a location where it's possible for us to look above and below the plane of the Milky Way galaxy itself, which allows us to look deep into the cosmos. If we were within a spiral arm, for example, or closer toward the center of the Milky Way, then we would just see Milky Way stars all around us. We would have great difficulty seeing outside of the Milky Way and not be able to perceive this vast universe that the Milky Way exists within. So not only is our location designed for life, the location within which the Lord has placed our sun, it's also been placed in a location that's appropriate and good for observation and gives us the ability to perceive more of his glory than we otherwise would be able to do. And there's a lot of other arguments for designed characteristics that we could talk about. This book here was written by two secular authors. Again, they're not arguing for the existence of God, but they are saying, you know, our Earth is really unusual for a wide variety of reasons. And I'm just going to mention a few of them here, because we're going to take the secular view to its logical conclusion and ask the question, is it really reasonable to say that all of these things are just accidental? For example, our solar system, these authors have pointed out that it is perfectly set up for life to be possible here on Earth. Turns out you can't have another Jupiter or a Saturn within a solar system for life to be possible here. You can't have giant planets in eccentric orbits because they would interact with other planets frequently, nor can you have hot Jupiters where a Jupiter-sized planet is closer to the sun than ours is. You do need a Jupiter because Jupiter protects us from potential impactors coming in from space, as I mentioned in my last talk. But you can't be too close to it, and you also can't be too far. It has to be just right in its distance. In fact, there's a large number of characteristics that the Earth needs to have to support life here from an evolutionist perspective. And again, not all of these will apply to a young age thinker like creationists are. But I do think it's interesting that the Lord has created everything in such a way that even if you want to deny that he is the creator, even if you want to believe in the billions of years and everything happening by random processes over long periods of time, that you still have to deal with the fact that all of these amazing coincidences appear to be necessary in order for life to even be possible here. And obviously, I'm not taking the time to discuss any of these because there's other things I want to cover. but hopefully you're getting an idea of the variety of factors that are in play here. And this does not only involve the Earth, by the way. We talked briefly about things like our location within a galaxy, but even the cosmos itself turns out to be finely tuned. Even the laws of physics and constants of physics themselves and properties of atoms themselves, the basic fundamental things that the universe is built from and operates from, those things appear to be finely tuned. For example, Sir Fred Hoyle was studying the properties of the carbon atom, and he certainly was no friend to creationism, but he concluded this as a result of his research. He said, some super calculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Now, again, he didn't accept that the God of the Bible was the super intellect, but he argued that there must have been some sort of super intellect behind all of this, because even the properties of atoms appear to be so finely tuned and well designed. Another author said this, and who this is might surprise you. He said a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants appearing in our theories appear fine-tuned. If they were altered by only modest amounts, the universe would be qualitatively different, and in many cases, unsuitable for the development of life. Again, this man is an evolutionist, so he believes life developed. That's impossible, as we've said. But even if you think in those terms, you're forced to acknowledge design here. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. Well, we're made of atoms, so that would be a very bad thing, obviously. Our universe and its laws appear to have a design that both is tailor-made to support us and, if we are to exist, leaves little room for alteration. That is not easily explained. It raises the natural question of why it is that way. So who said this? Stephen Hawking, a militant atheist. Even he admits that the universe and its laws appear to be designed to support us. Because indeed, the entire universe has extreme fine-tuning. Even if you accept the secular models, you're forced to deal with this fact. Here's an example. A few years back, some scientists were working with the Big Bang model in the earliest stages of it. And the Big Bang model is extremely sensitive to the amount of matter that supposedly popped into existence from nothing, because there's a real tension in the early parts of the model between gravitational attraction of the matter to itself and the expansion that's forcing the universe to get bigger. So gravity is trying to pull the universe back in to make it smaller. Expansion is trying to force it to become bigger. The model has this knife's edge, if you will, this razor's edge that has to be walked, if I can abuse my metaphor here, in order to produce the universe that we see today. Now, again, I don't accept the Big Bang model. I don't believe it could make a universe. But even if you do believe that, then you have to say that there's an extreme sensitivity here. If there's too much matter in the beginning of the model, then gravity becomes too strong relative to the expansion. It overcomes the expansion. Everything collapses back upon itself, and all you get is black holes. There's no stars, there's no planets, there's no life, there's no us. On the other hand, if there's just a little bit less matter than what we see in the universe today, then gravity loses to expansion, and expansion dominates, and everything spreads apart too fast, and stars don't form, galaxies don't form, planets don't form, life doesn't form. We're not here to talk about it then either. So the early Big Bang universe has to have the exactly precise amount of matter to explain the universe that we have today. How precise? Well, the precision has to be 1 out of 10 to the 60th power. Now that's just a big number. What does that mean? Well, here's an illustration of it. There's about 10 to the 80th power atoms in the whole universe. Well, if the Big Bang model produced this universe but it had to be finely tuned to 10 to the 60th power, you can divide one to the other and see that the precision of the Big Bang model is 10 to the 20th atoms. So that's the amount of matter that the Big Bang could have varied. That's the margin of error, so to speak, for the Big Bang to be able to be consistent with the universe that we see. Well, 10 to the 20th atoms is about the amount of matter in a single grain of sand. So imagine how vast the universe is. I mean, picture you're outside looking at the night sky. All the stars you see and the galaxy it's within, and then all the galaxies beyond that. The vastness of the cosmos. The Big Bang supposedly made this, but if it had made one extra grain of sand anywhere in the cosmos, then everything we see wouldn't be here because it would all just be black holes. On the other hand, if it had made one grain of sand less worth of matter than what we see in the cosmos, we wouldn't see the content of the cosmos either because it would all have expanded too quickly. So this supposedly random event that happened without a creator had to be finely tuned to a single grain of sand across the entire cosmos. Does this sound like a random event to you? Well, most people would argue no. This problem is pretty bad if you're a secular thinker and want to exclude God from your thinking. But since this calculation, the problem has actually gotten worse. The fine-tuning is now up to, in the Big Bang model, is now up to 1 out of 10 to the 123rd power. That's 1 out of this number is the precision of the fine-tuning for the Big Bang model to be viable. And again, it has other problems, other reasons it doesn't work, but we're setting those aside for now. As this author said, our universe appears surprisingly fine-tuned for life, in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. So back to our analogy, if there's 10 to the 80th atoms in the universe, but the fine-tuning is now up to 10 to the 123rd power, well, that means your precision is now 10 to the minus 43rd of one atom. So now we're talking about fine-tuning that's less than a grain of sand. It's less than one atom within a grain of sand. It's this fraction of the mass energy of a single atom. This random event without a creator, without a designer or fine-tuner, supposedly did this. As this very secular physicist said, this is a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the universe had to somehow form in a way conducive to man being here. And you can tell what he thinks of that idea by the adjectives he uses. Because saying that the universe had to form in such a way to support human life, we're starting to sound more like a theistic explanation, aren't we? And if you don't want that in your thinking, then that explanation is reviled and despised. And there's really only two explanations for this type of fine-tuning in the cosmos. Either the cosmos is designed, a designed cosmos has a designer though. So if you don't want the designer, well, your other option is a multiverse. What is a multiverse? Well, multiverse means multiple universes, and this is the solution to the problem that's being proposed by secular thinkers now. So there's multiple universes out there, an infinite number, in fact. And so even though our universe appears very unlikely, and they will admit that it does, that doesn't matter because there's so many universes out there that every possible combination of characteristics is out there a whole bunch of times. And so even though our universe looks astoundingly well finely tuned, we just happen to live in one of these unusual universes in this vast sea of universes in the multiverse. Now, you might be wondering, first of all, well, how can there be multiple universes? I mean, if the universe is everything that there is, how could there be multiple everythings? Well, they'll redefine the word universe. The word universe in this context, sometimes it still means the old meaning, but in this new context, now it means everything we could possibly observe. Now, we can't observe our entire universe yet because our technology keeps getting better and so on. But even with the best possible technology, there are limits to how much of physical reality we can see. The limit to that, everything within that limit, is our universe. Everything outside of our ability to perceive, that's all in a separate universe. And the assertion is now being made that there is an infinite number of other universes that exist. And so this explains, therefore, the fine-tuning problem. There's just an infinite number out there, and we just happen to live in one that looks amazingly well finely tuned. This is now, by the way, an integral part of the Big Bang model. The Big Bang model includes cosmic inflation at the very beginning of the model. And although they didn't realize this at first, it has since been shown that inflation will produce an infinite number of universes. So the Big Bang model now will produce, according to those who believe the model, an infinite number of bubble universes. Universes have been bubbling off from this eternal inflation process for an eternity. It's been happening forever long, and it will continue forever long into the future. There's an infinite number already, and there will continue to be an infinite number more perpetually being created. So this, although this idea seems very strange, this is actually welcomed by many Big Bang thinkers because they think this solves the fine-tuning problem for them. The Big Bang model produces an infinite number of universes. Therefore, this allows them to escape the implications of our particular universe looking very well designed for us to be here. But let's think about the implications of an infinite number of universes existing. For among other things, this means there's an infinite number of universes out there just like this one, where we're having the same webinar right now. There's an infinite number of universes out there where we're having the same webinar right now, but you had something different for breakfast this morning. On and on it goes. Every possible variation of history you can think of is out there an infinite number of times. As this article said, is there another copy of you reading this article? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities, in a solar system that's just like ours. The life of this person has been identical to yours in every respect. You probably find this idea strange and implausible, yet it looks like we'll just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a faraway galaxy. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. We're going to come back to that phrase, by the way. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many with people with the same appearance, name, and memories as you. They are you. You're out there an infinite number of times. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. A couple implications of this. First of all, if there's an infinite number of copies of you out there, are you a unique person who's valuable and made in the image of God? You're just one of an infinite number of copies. This has some real implications on ethics and other areas of philosophy, doesn't it? But focusing on the scientific aspect of this, I'm going to concentrate on this phrase. Even the most unlikely events must take place somewhere. There are many books being written on this idea now. This is mainstream within cosmology now. These are just the books I could fit in the slide. There's many others I could have included. And there's even scientific papers being written on this idea. Again, this is mainstream and it is now part of Big Bang cosmology. As this author said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing like can you supersize or not, says this theoretical physicist. Our own cosmological history, he says, tells us that it's there and we need to deal with it. So even if you think this idea is strange, and I would agree with you, we need to just deal with it because this is now part of cosmology today. This is mainstream and allegedly is good science. But is it really? What is the one thing we know about all these other universes? I mean, by definition, because they're other universes, they are unobservable to us. There's no way to observe, to confirm or deny their existence or their properties. This puts them outside of empirical investigation, and one would think outside of science. Moreover, if they are unobservable, they are outside of the natural world and the natural universe that we can see and observe. What word did we apply to something outside of the natural world? Supernatural. That's what the word means, right? Multiverse theory is inherently a supernatural idea. Yet earlier, as I mentioned, we are told that we are not allowed to talk about the Bible in this discussion because it's a supernatural explanation. Does anyone else besides me see some real hypocrisy going on here? And even some secular thinkers have problems with this. As this author said, these multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination, unconstrained by evidence. This author said, my own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks and becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience. But even beyond those issues, the multiverse idea, the multiverse outlook, has a larger issue that I'm going to talk about now. It has implications that are absurd. In Matthew 7, Jesus said, "You shall know them by their fruits." Now, if the Big Bang model, which again includes multiverse theory now, if the Big Bang model were a good scientific model, then it would have good scientific fruits. But if it's a bad scientific model, then it will have bad scientific fruits, or even fruits that are absurd. So let's talk about the implications of the multiverse theory, which again is part of the Big Bang model now, and ask, is this really science, or has this turned into science fiction? Well, what's in the multiverse anyway? Well, basically everything you can think of. As this author said, there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out. Well, think about that. That means, among other things, that Captain Kirk and Mr. Spock are real people. They're out there in the Starship Enterprise in an infinite number of universes doing everything that Star Trek said that they did. Every episode of Star Trek is real. Even the ones that are painfully cheesy and hard to watch. That's all out there an infinite number of times, if the multiverse is true. Now you think that's kind of a stretch, but no, remember, even the most unlikely events must take place somewhere. It's out there according to the multiverse. I hate to use the word theory, idea. Another author was not writing about the multiverse specifically, but his same logic applies. He was worried that as we explore other parts of the cosmos, we're going to run into planets where dinosaurs evolved just like they did on Earth, but they were not wiped out by an asteroid collision, as he believes they were on Earth. And so those dinosaurs continued to evolve. So he warned us, he said, such life forms could well be advanced versions of dinosaurs. If mammals did not have the good fortune to have the dinosaurs wiped out by an asteroid collision, as on Earth, we would be better off not meeting them. Yes, you don't want to encounter an advanced dinosaur because there's nothing worse than running into a dinosaur that has better weapons than you do. Now, obviously, I'm having a little fun, but this is really, according to multiverse theory, there are planets where dinosaurs continued evolving and actually have advanced weapons. In fact, there are planets where humans are fighting advanced dinosaurs right now, according to this idea. But is it science, or is it just science fiction? Now, obviously, I'm having a little fun with this, but if multiverse is real, you just saw a documentary. Other implications of this idea. This author said, in all seriousness, it is proposed that our universe was created by life of superior intelligence, existing in another physical universe. Intelligent beings might possess not only the knowledge to design, but also the technology to build universes. This explains why the constants of physics have their observed finely tuned values, and might even help us to understand why our universe is comprehensible to the human mind. So that's his answer. That's why the universe looks so well designed. Not because God did it, but because aliens did it. But is this science, or is it just science fiction? Another author wrote this. Again, he's serious about this. It is a perfectly acceptable supposition that the world as we know it is a vast computer program run on machines built by an intelligence we know nothing about in a universe that could be like any of the ones we speculate about, or one that is totally strange and alien. So let me stop here for a moment. Remember, for the sake of my discussion here, we're thinking like consistent atheists and evolutionists. A consistent atheist has to believe that there's he has to be a materialist, that things that are immaterial can't actually exist because the Big Bang only could make four things ultimately: matter, energy, space, and time. Those are all material things. The Big Bang could not make anything such as consciousness. Therefore, consciousness does not actually exist. It's really an illusion. And there are many atheist thinkers out there who have written books on this, making this argument. So if you're thinking like an atheist and an evolutionist, well, then the world around us is just this physical thing. We could actually be not conscious beings, because there's no such thing as a conscious being. Maybe we're just artificial intelligence. Maybe we are part of a vast computer program being run by aliens somewhere else in a different universe. He says, if you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes, there would, in all probability, be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of the universe. Why is that? Well, mathematically, once you buy into their way of thinking, you have to say that mathematically it's overwhelmingly probable that our universe is not real. Think about this. Our one physical civilization, human civilization, has had computers for decades now. How many simulations have we run on our computers since we developed them? Well, who can count that number, right? Some large number. If you're thinking like an atheist and you're thinking that technology will eventually get to the point where you can simulate an entire universe, well, then that civilization with that capability will, after a long enough period of time, produce millions, maybe billions of computer simulations of universes. Therefore, when you wait long enough, or if there's a large enough number of universes for this to happen within, there will eventually be millions or even billions of simulated universe to every real physical universe. Therefore, we find ourselves in a universe, but the chances are millions or even billions to one that we're actually in just a simulation of a universe and not a real physical one. So even though it seems as if we live in a real physical cosmos on a physical planet orbiting a sun within a galaxy, that's all an illusion because we're just living within a video game being played by some alien somewhere. Now, you may think this idea is silly, but no, they are quite serious about this idea. In fact, there are people researching and investigating to try to figure out if this is true, if we do actually live in a simulated universe instead of a real one. And if you're laughing right now, you might want to rethink your amusement because, among other reasons, this study was partially funded by the Department of Energy. So if you're a US taxpayer, as I am, you paid for this research. These are our tax dollars at work here to figure out if we live in a simulation being run by some aliens. But let's think about that. If aliens could eventually get to the point where they can simulate entire universes on their computers, well, they can also simulate universes that contain aliens that are simulating universes. So maybe there's multiple levels of simulation, as this author said. Maybe the computer our universe runs on could be itself a simulation on another computer. So it's not merely that we're living in some alien video game. Those aliens themselves are living within a video game being played by some other aliens. And why stop there? Maybe there's multiple layers beyond that. Maybe those aliens are part of a video game being played by other aliens, which is part of a video game being played by other aliens, and ad infinitum, you get the idea. Now, obviously, we have left science far behind at this point, even beyond science fiction at this point. This is bad science fiction, if anything. Yet, this is the logical implications of multiverse theory. This is where you wind up when you take the secular view to its logical conclusion. You end up firmly in absurdity. Now, we talked about fruit, right? If the fruit is bad, that tells you that the thing that made the fruit is bad. If the implications of multiverse theory are absurd, then the Big Bang Theory, which includes multiverse theory, is itself absurd as well. So we can ask the question, why then is this still being promoted as good science? Why are so many secular scientists who are very intelligent men and women, why are they still believing in this model and trying to develop it and promoting it and so on? Well, here's why. If there is only one universe, you might have to have a fine tuner. If you don't want God, you'd better have a multiverse. These thinkers clearly recognize their choice. The universe looks like there is a fine tuner. It looks like there is a designer. That means that there is a God. If you don't want that, your only other option is to accept the multiverse despite all of the other baggage that comes with it of absurdity and so on. So what's happening here? We are often told in our society that science disproves the Bible, and that's why so many scientists are not believers in the Bible, because they say they're just following science where it leads, and it leads them to the conclusion that there is no God because we know about the billions of years of evolution, and that's how we got here, etc. Multiverse shows us that that's not actually what's happening. What's actually happening is this: scientists are rejecting God first, Therefore, that's why they're claiming that science disproves the Bible, because that's what they want it to show. And they will continue to do that regardless of how absurd or impossible their models wind up becoming. They are excluding God from their thinking first, and then that forces them to a place where you would hope they ultimately wouldn't want to go, into true absurdity. The Bible says that the fool has said in his heart, there is no God. And that's ultimately what is happening here in cosmology. People are winding up in foolishness. Now, don't misunderstand me. I'm not saying these people are stupid. Again, they're very intelligent men and women. But when you reject the truth, then whatever it is you wind up believing has to be a lie. The Bible says that the fear of the Lord is the beginning of wisdom. Well, if you reject the Bible, then you're rejecting wisdom. And when you reject wisdom, whatever it is that you wind up believing has to be foolishness. And we see that in modern cosmology today. This is not a battle of religion versus science. The science is on our side. The cosmos looks designed. It is consistent with our viewpoint, not with theirs. Our cosmos is finely tuned and designed. There is a designer. That's because the universe did not form in a Big Bang billions of years ago. Our solar system did not form from a cloud of gas, etc. The heavens declared the glory of God, and the firmament shows his handiwork. And he has graciously allowed us to perceive evidence of that within the cosmos that he created. He didn't have to do that, by the way, but in his grace, he has placed us within a universe that looks created. And indeed, the cosmos declares his glory in so many other ways that we cannot even begin to comprehend. So this is my site, as Dr. Locklear mentioned, creationastronomy.com. Again, there's a sign-up form there for a newsletter that presents an occasional email with this type of information in it. If this appeals to you, you will also see some DVDs for sale there. My first presentation on the solar system was excerpted from volume 1 on the solar system, as you see there. The material in this talk came out of volumes 2 and 3 on stars and galaxies, and then on the universe. And there's actually several hours more of material on those 2 DVDs combined that I did not have time to discuss in my presentation here today. So thank you very much for your attention. I hope this has been helpful and useful, and can maybe help you appreciate the heavens in a way that perhaps had not occurred to you previously. And Dr. Locklear, what do we want to do now? I'm right at the end of my time. Do we want to stick around for a few questions or no?
Sure, I think we can do that. First of all, thank you very much, Spike. Excellent presentation, as everybody is talking about. I'm going to start off with a question that probably related to your first presentation more, if you don't mind.
Okay.
The question is, you spoke about the ocean tidal bulge. Why does the bulge appear on both sides of the Earth rather than just the side that the moon is on?
Oh, I actually posted an answer to this in the
Oh, I'm sorry, I missed that.
in the Q&A. Well, the problem is once you answer the question, it disappears and it goes over to the other thing. But the answer is that at the risk of seeming to do shadow puppets here. So if this is the Earth and this is the moon over here, the ocean water will be pulled toward the moon directly. So there'll be an ocean bulge underneath the moon. Now, in the actual system, it's offset a bit because the Earth is rotating and dragging it forward a bit, but forget about that. So on this side of the Earth, the water bulges directly out. On the sides, it is pulled as well, but to a lesser degree. So the water on the sides, the top and bottom, so to speak, will flow toward the moon, thus thinning it out. Because gravity is weaker over longer distances, the water on the far side is the least affected by this. So more of the water will remain over there. So it appears to be like it's bulging outward, but what's really happening is the rest of the water is being pulled away from that. So hopefully that makes sense. It's not that the water is bulging outward, it's that the rest of the water is being pulled away from that, leaving what appears to be a bulge behind.
Good. One other one I think we'll get to. Speculation. I wonder if God created this amazing and vast universe partly so that we could eventually travel through and explore it. Any thoughts about that?
Boy, I'd love if that were true. Not in my lifetime, probably, or any of ours, but yeah, wouldn't that be wonderful? I think a large part of it is just the ability to perceive his majesty, his power, and the knowledge that the creator of all this is Christ, as John chapter 1 says, and a few other places, and that the one who spoke this all into existence nevertheless loved us enough, even in our sin, to take on our form and come here on earth with us. um, that still staggers me. It's beyond our comprehension. What the universe tells us about God's grace. Obviously his glory as creator, his as a designer, as a brilliant engineer beyond our ability to understand all of that. But for me personally, it really helps, even if to catch a glimpse of what it means for God's graciousness and sending a savior who was the creator also. And I know I'm not saying this very well. I hope I'm trying to communicate this. I think there's many aspects to God's character that the scale of the universe can communicate to us, and not that we can ever comprehend it fully. But I'm thankful to live in an era where we have the scientific technology to even perceive these things. Much of this was not known through human history until just recently. So we are able to see things that previous generations of people were not. And despite all the problems that we have in modern society, always challenging, nevertheless, I'm thankful for the ability to see some of these things in astronomy. I know that wasn't expressed very well, but
No, that was well said. Well said.